number 8 for Unit 2. So, what percent of the square is shaded? What percent of that square is shaded? Can I give you a second? And the way you're doing, and that's a good idea. Looks like y'all doing this kind of thing where you like fill that in. That looks like a good way to go, I think, too. Then you could just count them, huh? You could just say, okay, so there's like 1, 2, 3, 4, 5, 6, 7, 8. Why did I fill in that gap? Like if you were to show this to a young person, they would say, why are you filling in that gap? Why are you putting in that line like that? Why am I?
To make them equal segments.
They make them all the same, huh? Exactly, make them all the same. Because if we make them all the same, then what portion is shaded?
25.
2 out of 8.
Yeah, 2 out of 8, and then we can reduce it and stuff. But right, does that make sense? 2 out of 8 are shaded, exactly. Then you can reduce that to be 1 out of 4, right? Because that's the same thing, 1 out of 4. And then what percentage is that? 25. Some of you already know. Good. Why? How would you explain to a young person why that's 20, or to anybody who wasn't sure, why is that 25%? How do you know that's 25%?
So if you put it to like maybe 4 quarters, $2, 1.
So money is an excellent way to go. Let me tell you straight up though, that's great for adults. Kids haven't dealt with money a lot. But yeah, for you all, another college student or any adult, yeah, money, we all do money all the time. So we just know $0.25, 25 cents. And probably some kids do in the upper grades, but not as much as we do. So that's one good way. What's another way? How would you explain that 1/4 is 25%? Or 2/8, either way, is 25%? Like, why is it? How do we come up with that number? Any thoughts? What is percent? Somebody used to say, what do you mean? What is that? 25%. What's percent?
Per 100.
What is it?
Per 100.
Per 100? Is that right? Is percent per 100? Yeah, how long is a century? 100 years. Yeah, cent is 1/100th of a dollar. Cent, it means 100, doesn't it? Whenever it's in front of a word. C-E-N-T. A prefix means 100. Yeah. So percent means per 100. Okay. So when we say 25%, what we're saying is 25 per 100. By the way, that's why there's the 2 zeros in the symbol, huh? Those are like the 2 zeros in 100, aren't they? I don't know if you've ever wondered or stayed up late at night going, why are there 2 zeros? And I know, just weird math teachers do, I know. But there you go, mystery resolved. Anyway, so, okay, we're still sort of in the middle of it though, really. 25%, 25 per 100. But why is 1/4 25 per 100? Why? How would you explain that to a young person? If they ask too many questions, you can just say, don't bug me, kid. Just do what I said. No, but we want to give them reasons, right? So, what would be a good logical reason? Why is 1/4 or 2/8 25 per 100? How are those the same? If we wrote it out a little bit more, would that help? Why would 1/4? How about you say it to your table? If you don't want to say it out loud in front of the whole. So what if I said, there are a bunch of elementary students on campus today, did you notice? All right. So what if I said, hey, there were 100 elementary students walking around in a big section, and 25 of them had hats on. Let's just say that. So 25 out of 100 were wearing hats. What portion of the crowd was wearing hats? 1/4, I thought. Right? And how could we get that answer? Yeah, it's just reducing a fraction, isn't it? It's just reducing a fraction. 25 out of 100, if you just divided top and bottom by 25, whoop, can't make a 25 there. 25 divided by 25 is 1, and 100 divided by 25 goes into 100 4 times, huh? So do you see that percent is a type of fraction, really? And it's the same as 1/4, isn't it? If 25% of the kids are wearing hats, so this works not just for 100. What if there were like 10,000 kids on campus today? That there weren't 10,000, but what if there were like 10,000? Or you're watching a baseball game, let's say, or this basketball season. You're watching a basketball game, and you're saying, yeah, there were 10,000 people in the auditorium to watch the basketball game, and 25% were wearing hats. Now, what does that exactly mean? If you're looking at like 10,000 people at a basketball game, and you say 25% wore hats at the game. So, what are you saying exactly? How many people wore hats?
2,500.
Good, you're coming up with a number. But how would you describe it without doing such a good? That's a good job though that you can calculate that. How would you describe it in a way that makes sense? What are you saying? 25% of the crowd wore hats. What does that mean? We could say the fraction we already said, right? 1/4. But then that might require some explanation. Couldn't we say 25, and what's percent mean again? Per 100? In other words, if you took those 10,000 people in the crowd and you broke them into nice even groups of 100, and every group of 100 there'd be 25 hat wearers. Does that make sense? 25 per every 100, 25 per every 100, etc. That's what we're saying when we say a percentage. This section, as you can tell, is all about percentage. So I want to make sure that's super clear what it really is in your mind. We're saying per 100, aren't we? We're saying, and it doesn't mean there's exactly 25 hat wearers, you know that. It just means 25 per every 100. If you broke the gigantic crowd into groups of 100, you spread out the hat wearers evenly, there'd be 25 in every 100 that are wearing hats. That's what we mean by percentage. Okay, so with that in mind, express the number as a percent. So how do we take, let me get a fresh screen for us. How do we take just like a plain old decimal number like 4.23, which is not a percent, doesn't have a percent on it, and then I want to write it as a percentage. So when I say write it as a percentage, I mean equal to. I'm going to make it look different without being different. Right? That's the deal here. It's changed, it's got to have a percent symbol on it, but still be the same as it was. So now you might think, well, can't I just go 4.23%? That can't be right. That can't be right. It can't just stay that same way. Everybody get what we're trying to do here? We're trying to make it look different without being different. I always call that plastic surgery. We're removing the wrinkles so the person looks different without, it's still the same person, right? So we want the value here to be the same, and we just want it to look different without being a different value. We do that all the time in math. I call it plastic surgery, just to use a weird word and help people remember, stick it in their mind. I'm hoping to with that phrase. So we're doing plastic surgery, different look, same value, same person. So what's the deal here? Any ideas? What number can I put here that'll be the same as this, but this one will have a percent symbol on it? That percent symbol is not just decoration, right? It's going to make a difference. Noel? 423. What do you think about Noel's idea? What makes you think that, Noel?
If you put 100 under it, it would be 4 as a whole, and then it'll be 23 over 100.
Nice. I like the way you're thinking. Yeah, do you see what he's saying? Do you see? He's saying put 100 in. Now, why are you saying put 100? That's a great thing to say. Why are you saying that? What's making you put 100 underneath it? Because that's what it means. Exactly. Are we all dialing in with what Noel said? He's exactly right on track, right? So let me make sure a couple things are clear. I bet they are, but I just want to make sure to follow what Noel's saying. You've got to make sure he's right on. Is everybody there that, like, if you take any number like 7.3 or whatever, and you divide by 10, let's just start with 10. What does that do to the decimal if you divide a number by 10? Where's the decimal go, right or left? If you divide by 10, it gets smaller, huh? Dividing by 10 so it's going to go, left. 0.73. So if you take 7.3 and you divide by 100, so 2 zeros, where's the decimal going to go?
2 spots.
2 spots left, and then that's going to, the first spot jumps over the 7, The second spot brings in 0.073. Okay, so that's right. That's what Noel was saying. He was over there saying, well, this means over 100. That's what that symbol means, right? Noel's right on the money. Per 100. So that means divide by 100. When I put that symbol there, I'm saying 423 per 100. I'm saying 423 divided by 100. Well, what is 423 divided by 100? Where's the decimal right now? It's there, but if you divide by 100, it'll go 2 places back. Perfect. So that's right, isn't it? Does that make sense? Good. All right. And number 3. Can you try the same thing there? So they're going the other way, you notice. So I'll give you a second. Try it. Compare with those at your table. Clear. It's starting with a percent, and over here there's going to be no percent. That's what they wanted. They want you to write it with no percent. The value is. Value? What do we think? 0.19? Why do you think 0.19? Yeah, because wherever the percent symbol is, in this case, it's here. This side means 19 per 100, doesn't it? So wherever the percent symbol is, that's where the per 100 is, isn't it? So 19 per 100, of course that means 0.19 because the decimal goes back 2 places, huh? Exactly. That's why we move decimals back 2 places when we have a percentage, right? Rather than just thinking of it as a rule, it's what's true. It's what it means, huh? Always better to do that math that way. That's 19 per 100. You can read my scribbling there. So it divides by 100. So a percent symbol means divide by 100, doesn't it? It means move the decimal back 2 places. That's just the very meaning of it. All right, so now, good job. So on number 4, now we're going to do a bunch of little tiny parts of word problems with percentage. There's all kinds of different ways to do this. Some people, if you click on the show me an example, my math lab thing, they'll give the fraction way to do it. You can totally do that if you want to. I'm just going to show straight. I found it's easier for students over the years to just do these as straight equations. So I'll just take it straight. Here's what I mean by straight. Well, in fact, let me just rewrite it. What is 8% of 29? So I'm going to take it directly straight. Here we go. What, that's just going to be my x, because I don't know what that is what does is become in a little word problem? That's the equals, huh? That's the equals, because something is something, it's equal. 8%. Now let's go ahead and change that to a decimal. So that, you know that means 8 per 100. So what is that? 0.08, right? Goes back 2 places. Of, do you know what of means in a word problem? Multiply. Yeah, it always means multiply. 29. And then just use your calculator. So I just directly translated that statement. Just straight on down. Hit the buttons on your calculator. Somebody got that answer? Yeah, good. Thank you. 2.32. And we got it. Is that making sense? Let's try B. 20 is what percent of 80? So let's take it direct again. So I'm just going to go direct, no fractions, just direct translation. 20 is, what's the is? Equals. What percent, that's just going to be my x. Or you can write x percent if you want. Yeah, maybe that'd be better. X percent of times 80. So far, so good? So of is times, is equals. Now, how do we solve, we're always trying to solve for x, huh? How do we solve, remember from your algebra days, how do you solve that little equation for x? X is, and I won't be alone, what do we do? Divide, huh? Yeah, because that a is just times, so we just divide like that. So use your calculator, you'll get 0.25, right? Good so far? We're almost done, right? So the left side, 20 divided by 80, 0.25. Now what, we're trying to find x. What is x? What percent is 0.25? Yeah, 25%, as you know, right? Because that means, because 25 over 100, right, per 100 is 0.25. So we're done. So the answer is 25. They already put the percent symbol there for us. So we just fill in the 25. We good on that? Making sense? direct translation. You want to try C? Try C. Try that with the people at your table. Answer there. So part C, 15 is 30% of what number? So 15 is equals 30%. What do you do with 30%? That's 30 per 100, huh? So what's it going to be as a decimal? 0.3 or 0.30. Yeah. Hey, by the way, 0.3 and 0.30, are you good with the fact that those are the same thing, aren't they? That 0 at the back is optional, isn't it? It's just 0 hundredths, so it doesn't do anything. Of is times what number? That's our x. So how do we solve that little equation for x? Divide again by 0.30. 0.30. Use your calculator. Is it like
50?
50? Thank you. 50. Is that good? Does that make sense? How many got that? Answer 50? See where we're at? Okay, good. Most people are good. Hey, by the way, it's really easy on a test or homework, stuff like that. Hit the wrong buttons, just, by decimal or one. What if you got like the answer 5 instead of 50? Just accidentally moved a decimal wrong one time. Easy to do that. What would help you to catch yourself so that you don't put in the answer of 5? Look at the words right there. Would 5 be a fitting answer? 15 is 30%. So 30% is like about a third, huh? It's a small part. 15 is 30% of 5. Could 15 be a small part of 5? That can't be reasonable, huh? So always try to check it for reasonable all the time in math. It's always best if you just kind of read back your answers for general reasonableness, because we can all hit a wrong button. If we put in 50 there, and we go, okay, 15 is a small part of 50. Yeah, it is. That seems fitting, doesn't it? That seems right. Yeah, good to do that. All right. And D will be easy. I'm going to move on. So number 6. Okay, during a sale, a dress decreased in price from $80 to $72. What was the percent of the decrease? Yeah, can you figure that one out? Yeah, try that. Tell me your thoughts. Okay, let's dial in. She's got a comment. Let's dial in.
What I did, I subtracted 80 minus 72 to know like the amount they reduced from the original price.
Okay.
Which was 8. So then I divided 8 into 80 to know how many times 8 goes into 80. And then that's 10. So so it was 10% of the original.
10%.
Yeah.
I'm sorry, I don't know. You are Sandra. What? Sandra, why did I mark you absent? Anyway, you're good.
Yeah.
Oh, did you come in right? Okay, I got you. Anyway, Sandra. Okay, good. I like what you're saying. Tell us why. So first, did you ever hear what Sandra said? She said the price went down $8. Certainly that's true, right? The price went down from 80 to 72. So that's the price of that dress dropped by, so it went down $8. Good. Now, you said from there,
I divided 80 by 80.
yeah, Sandra, why did you do that?
To know how many times 8 could go into 80.
Yeah, but why 80? Why didn't you do the 72?
Because that's the original price. I want to know from the original.
Do we always have to do the original price? Or should we do the 72?
I think it's the original price because 72 is the outcome.
So what does a person mean? Let's think about what percentage means. If I said, what if I said half of that dress? What if I said half that dress, half of the cost of that dress is in the coloring of it, maybe, the dyeing, the color they put on it. What if I just want to throw out an idea. So let's say half of the cost of the dress is in the coloring. So what would that mean? Well, what's half the cost? It's half of what? What number? Half the 80. At least the original price before the sale. So in other words, she's exactly right, huh? When you talk about percentages and parts, you mean of the original, don't you? That makes sense? Anytime you're talking about a portion of something, you're talking about a portion of the original $80 price. So when we say the price dropped $8, we're saying what part is 8 of 80? That's what we're really saying, huh? The price dropped by $8. And what part of 80 is that? That'd be like if I said, hey, at the end of the semester, I think there's going to be 15 people that get A's. What portion of the class is that? What would I need to do to find out what portion that is, or percentage? 15 divided by what? The whole class number, whatever that is, right? So whenever we do a portion or a part or a percentage, fraction, it's all the same thing, isn't it? You always got to divide by the whole. And the whole original price of the dress is 80. So she's exactly right. 8 divided by 80. Yeah, then your calculator will tell you that's 0.10. And then what do we do from there? They want a percentage. So how do you make 0.10 as a percent? That's 10 per 100, isn't it? Right, because that's 10 per 100. That would move the decimal back. So it's 10%. Does that make sense? We good on that? You want to try number 7? Let me make Mort and his house there. Basically, 329, 250, decrease. So basically, you don't need all those words. How about I just go? Now it's off the screen. 329 to 250. So 329,000 down to 250,000. What percent decrease? All right, so what do we do? Percent decrease. So a percentage is always a part over the whole, isn't it? Are you getting the hang of that? So it's always a portion. In fact, it might be good for me just to mention right now. Do you realize that percentage, decimal, and fraction are 3 languages to say a part of a whole? So in other words, I can do a new twist on the old story. Remember the old, how full's the glass? That's not a very, it's my best artistic effort right there, or close to it. So, how full is the glass? That's just terrible. That picture's just bugging me. I mean, I could do a little better, I think. Okay, that's a little better. That's kind of wrecking it now. But anyway, how full is that glass? You know, half full, half empty. You know that whole thing. Are you an optimist or a pessimist? But I want to put a fraction twist on it. That glass is half full. That's how you would say it as a fraction. How would you say it as a decimal? That same amount of water? 0.5 as a decimal. And how would you say it as a percentage? 50%, because that means 50 per 100, right? Those are all saying the same thing, aren't they? That's what this section's all about, and the next section is getting really, really comfortable with those 3 languages. It's like me saying one, uno, or that's one in French. So, right? 3 different languages, I'm saying the same number. So that's what decimal, fraction, percentage, they're just 3 different languages to say a portion of something, aren't they? A part of something. Not all of it, but a portion of it. So getting back up here with this one. So if we're saying what portion of the price decreased, that's what they're asking us. Well, whatever that difference is, what's the subtraction there? Oops. 329,000 minus 250, 79,000. So that's how much it went down, right? That's the actual amount it went down. But we're trying to figure out what part of the whole that is. So that's what you're always doing with a fraction, decimal, or percentage, is what part of the whole. So what part of the whole is that? That's 79,000. That's the part that went down. Of the whole, what's the whole? The original. Right? And then just use your calculator, huh? So somebody got that? What is that? 24? Comes out. So this comes out 0.24? And then you change the percentage. So it'd be 24%, right? This is the decimal version. That's the percentage version. They're both saying the same thing. This is the fraction version, unsimplified. Those are all saying the same story, aren't they? They're saying, 24 per 100, or 0.24 hundredths, right? Or 79 over 729. Those are all saying the same thing. That's the part of the whole that went down. That's the amount of dollars out of the whole dollars that it went down. That price dropped 24%.
Mr. Hearn, would
Yeah.
it matter that I rounded off because when I worked backwards, I multiplied 24% times 329,000.
And it came out a little different than 79. Came out a little smaller, didn't it?
Yeah.
78, 9 something, right?
Yeah, so there's like a.
Because it's not exactly 24%. So if you multiply backwards, it won't exactly go back.
So on the homework, do you want us to like round it off?
Yeah, they'll tell us. Oh yeah, there you go. Round to the nearest percent. Yeah, they'll let you know. Yeah, so good question. We'll just round to 24. Yeah. Good. Is that good? All right. How about number 8? A $250 suit is on sale for a 20% discount. What's the sale price? So try that one. All right. So $250 suit, 20% discount. So we need to find, don't we, 20% of the 250? And then we got to discount that amount. We got to find out what 20%, that part of the whole 250 is. So 20% as a decimal, 0.20, because it means 20 per 100, right? That's what percent means, which moves the decimal back 2 places. Of, what does of always mean? Multiply by 250. Doesn't that come out 50 bucks? So what do we do with that 50 bucks? Subtract it from the original, huh? And that leaves us with $200. So the new price would be $200. Does that make sense? We just took off 20% of it. All right. How about I think number 9, same thing. I'm going to move on. Number 10. What percent? Gets easy. Number 11. Start report at 75%. How many employees here? I think it's easy. I want to get to the hard ones. Ernie borrowed. Okay. Ernie Rolfe borrowed. I'm down to number 12 here. $57.50 at 2% annual simple interest. Exactly 1 year later, was able to repay the loan. How much interest? But yeah, that's easy as well. All right, so I'm going to details here. So for 13 through 15, A is the amount later. What is this formula? This is compound interest. You might have seen it before. Compound interest. P is the principal. Invested at the start. R equals the rate, the interest rate. And N, which is in 2 places actually, N equals the number of compoundings per year. Number of compoundings per year. So that N would be, for example, 2 if they said it was semi-annual compounding. Or N would be 4 if they said quarterly compounding, right? That'd be 4 times a year, 4 quarters in a year. N would be 12 if they said monthly compounding. N would be 365 if they said daily compounding. And the last piece of the puzzle, T is years. All right. So there's our formula for problems 13 through 15. Compound interest formula. So you can put that on your 3x5 card for the exam week after next on Monday, a week from Monday. All right, so let's dive into using it if you've got that down. Let's try, what does 13 say? 55,000, company needs 55,000 in 7 years. Let me write it down. In fact, I'll let you copy that down. I'll put it down here. So number 13, 55,000 in 3 years. They need 55,000. Write that a little better. They need 55,000 in 3 years. No, 7 years. I better read the problem better. In 7 years. To meet this goal, 4% compounded quarterly. How much? Okay. So, oops. How much invested now at, what was it again? 4% compounded quarterly. Interest compounded quarterly. All right, so they need 55,000 in 7 years. They need to have that amount. How much must they invest now at 4% interest compounded quarterly? Okay, so we're going to use this formula. I'm going to erase some of my writing here, and we'll go up and we'll use that formula. So, hopefully you got that copy down. If not, you can go back to the YouTube. So, all right, let's put the stuff in there. So where does the 55,000 go? Let's start with that.
A.
Yeah, the 55,000 is the amount they want later, huh? So right, that's got to be the A, doesn't it? Is that making sense so far? The P, we don't know. The P is what we're looking for. They're asking how much principal now that will grow to become. What principal now will grow to become $55,000 later? And the interest rate? Yeah. And then we have to change that to decimal. We always put that in as a decimal. So what's that going to be as a decimal? 0.04. You know that's the same, right? Because 4 per 100. That's what it is, isn't it? It is 0.04. Over N. And N, yeah, it says quarterly. So that means N is 4 times a year, right? Every quarter, there's 4 quarters in a year. So N is 4 here. N is also 4 there. And what's the T?
7.
T is 7 years. So there it is. So you need to do that on your calculator. I don't know if you have do you have a calculator that can do it? Well, any calculator will do it. But let me help you with it. So we'll just leave this out here as 55,000. The other side. So this side, you're going to want to just go ahead and make this power 28, right? 4 times 7 is 28. So just put that into your calculator. 0.04, I think this will be 0.01, won't it? To the 28th. So it's 1.01. So it's 55,000 is P times 1.01 to the 20th. So you got to have a power button at the least on your calculator. And, you know, the easiest way actually would be to just divide it first and, well, I don't know, whatever, it doesn't matter. So I'll write it out. 55,000 equals P times, let's see, what's 1.01? 1.01 to the 28th. Oh, I'm getting a really big number. I'm getting 1.32129. It goes on and on even further. I just kind of cut it off there. You able to get that number on your calculator? Do you know how to do the power button on your calculator? It's different on different calculators. Yeah, on some calculators, it's an up arrow. On some calculators, it's like an X to the Y button. It's going to be one of those 2 buttons for power. So 1.01 to the 20. So you'll need a calculator that can do that kind of thing on the next exam. So 1.01 to the 20th, use one of those kind of buttons. I'm glad to help you when I hang out. Just take 10 seconds after class to show you where that particular button is on your calculator. So I'll get the 1.32 whatever number when I do that. And then how do we finish to solve for P? Gonna divide, huh? So now we just divide because that's multiply 1.3, 129, 1.3, oh, 1.32, 129, cancels, P equals, I don't know. I'm getting 41,000. Wait a minute, running out of room here. I'm getting 41,625. They want me around to the nearest dollar? Yeah, nearest dollar. So I'll just, 0.95, so it'll round to 626, I guess. So 41,626, that's what they would need to invest now that'll grow to become $55,000 later after 7 years. Is that good? You able to do that on your calculator? So you'll want some calculator that you get used to for the test a week from Monday that'll handle that. We good on that one? Let's try one of these with our last 4 minutes here. Let's try, if you're good with that. No questions on that one? So 14, 15 are basically the same. Let's see, which one would be more interesting? Yeah, how about 15? 15 is probably a little harder. Let's jump down to 15. So an amount of 1,000 is deposited in a bank at 8% compounded quarterly for 5 years. The rate then increased to 10% for the next 5 years. What was the balance at the end? So you got to do both. Yeah, so let me write that out for you. So basically what they're saying on 15 is they're saying 1,000, 8%, 5 years. Oh, we're not going to have time for both. All right, well, let's do the first half of it at least. So 1,000, 8%, 5 years. So 1,000 at 8% quarterly for 5 years. So $1,000 deposited in a bank at 8% quarterly for 5 years. Then at 10% for the next 5 years. Then 10% quarterly for the next, what did it say? For the next 5 years. All right. So basically we're going to do this twice, aren't we? We're going to use the AP1 plus R over N to the NT formula. So, and the 1,000, what did they say about 1,000? An amount was deposited. So this is the deposited amount. So they put 1,000 in an account at 8% quarterly for 5 years. So let's do just that first part right now. So where does the 1,000 go? Yeah, this time it's P, huh? This 1,000 is the P, isn't it? Because now it's the principal put in, right? Did you catch that back when I described what the A and the P were? The A is the amount later. The P is the principal you put in now that grows to become a bigger amount later. So 1,000 now. What's the R? Yeah, 8 per 100, 8%. So it's 0.08. What's the N? Quarterly, it's 4 again, huh? Quarterly is 4 times a year. And the T is 5. So that's a power of 20 up there, huh? So you can just figure that out. So that's 1,000. And this is going to be 1. I think that's 0.02, isn't it? To the 20th. So that's 1,000 times 1.02 to the 20th. I'm getting 1485. Now, you better actually use a lot of, I'm going to use a whole bunch of accuracy because I'm not done with the problem yet. Whenever you're in the middle of the problem and not finished, you want to use a whole bunch of decimal places because if you round abruptly now, it'll throw off the final answer. Does that make sense? We'll round at the end, but try to use a lot of decimals now. So now I'll squeeze in real quick the second part. So now that's the amount that comes out at the end of the first 5 years. Does that make sense? Now I'm going to start again for the second 5 years and do the whole formula again. What am I going to put in for the principal for the second 5 years?
That is.
Yeah, this will become the P, won't it? 1485, 947, right there like that. That makes sense? That becomes the new P, and I'll just go dot, dot, dot. You do the rest. Just the same. Well, I'll write it for those that want to see it. But it's all the same. 0.10 over 4 to the 4 times 5. And hit the buttons. All right, this is not due.